Thank you, Dr. Uh, Thank you, everyone, for joining me here today. I'm Amrit Shahi. I'm from Nepal, and as Dr. Choi told, I started my PhD in August 2022. And since I started my PhD, I've been working as a graduate research assistant. So for the first year, I worked as a graduate research assistant for CIR research team 396, and now I'm currently working as a graduate research assistant for CIR research 421. It is truly a special moment to present the work of my 3 years in regarding my PhD journey, and I want to thank uh, my supervisor, Dr. Choi, and all the committee members for their continuous guidance and support. And I hope this presentation and the result that I present today will contribute to the research as well as to the industry. So my PhD dissertation is on investigating factors for modularization and standardization decision on early project phase through qualitative comparative analysis. Before we move forward, let's see what we're going to cover. So I will start with background study, followed by the existing literature review, need and hypothesis of the problem that we are going to address, the research methodology that we are using to solve the problem, result and analysis of the research, and at the end, we will see what we conclude and what can be the future recommendations to the industry as well as for the future research. When we talk about construction, we know construction is one of the greatest pillar of the world economy, but with construction, there has been a significant challenges that come along. Cost overruns, schedule delay, safety and quality concerns, labor productivity, and labor shortages are some of the key challenges that the construction industry faces. If you look at the productivity alone, over the last 1 decade, the productivity of construction sector has merely grown by 1%, whereas at the same time, the productivity of shipbuilding industry and other manufacturing industries has grown almost double. And if we look behind what are the key reasons behind those industries having a better productivity compared to construction, we see the use of innovative technologies and methods like standardization and modularization that has helped immensely to improve the overall project performance and productivity, which also highlights the importance of standardization and modernization in solving the problems of construction sector. So before we start and move forward, we need to know what is modularization and standardization. So CII 2023 has defined modularization as a execution strategy that transfers work from an on-site location to the off-site location for improved project performance, and standardization as defined by CII 2019 as the development and use of consistent design to align with the stakeholders' objectives and scopes so that the schedules and cost and value can be optimized. So if you look at individual performance, the modularization can give 19.2% of cost savings and 12.5% of schedule savings, whereas the standardization gives 25% of cost savings and 15% of schedule savings. Remember, this is only cost and schedule. There are other multiple benefits like improved schedule, improved productivity, problem solving regarding labor shortages, and other things that they bring along. So what if we combine modularization and standardization? We know every construction project comes along with structure with fixed cost and a variable cost that changes along with the project scope and time. So, which is usually represented by the slope of line. Now, if we introduce modularization, then initially the fixed cost increases because we need early design fixation, we need to have some early procurement, and which increases the fixed cost. But on the long run, the variable cost decreases and flattens the variable line in the cost curve, which further flattens once we introduce standardization also along with modularization, because now we are using consistent designs. We are using there is a procurement benefit, there is a learning curve benefit for implementation, construction, and operation maintenance, which further gives additional benefits compared to the traditional method. So despite benefits, despite there is some value gain by implementing modularization standardization, the current level as indicated by Connor et al. In 2015 doesn't suggest that all the sectors have not been able to achieve higher level of modularization and standardization alone. If we look some of the industries like shipbuilding, as already mentioned, auto manufacturing, who are basically factory-based, they have been able to implement standardization and modularization to a better extent, whereas other industries like petrochemical, mining, highway, they have been not been able to achieve the optimal extent of both modularization and standardizations. And if we need to improve our project's value, if we need to improve our project's performance, then definitely all those clouds of different industries has to move to the left and to the right until a higher level of standardization and modularization is achieved. Moving forward, there has been numerous industrial reports on modularization that has been trying to implement modularization effectively. The latest one being CII 2023, and previously there are a few other studies like PPMOF and MODEX. Similarly, regarding standardization, also there has been numerous research reports that has done from industrial viewpoint, and both the reports on modularization and standardization suggest that modularization and standardization are the key solutions, enablers, technology, and methods that needs to be focused if we want a better productivity and overall better performance of the projects. So next question aligns why early project phase. Now, if we look at a survey done by CII in 2013, around 16% participants believe that the business case analysis for any modular project should be done at early project phase, that is opportunity framing, followed by 48% in assessment phase, which when done the similar survey in 2023, now most 42% of the survey participants believe no, it should be all focused on the opportunity framing. Why? Because if we decide early to modularize, then we can optimize, we can have the possibility of attaining the optimal solutions and getting maximum benefits that includes cost, schedule, and other potential benefits. That highlights the importance of early decision in modularization. Similarly, regarding standardization, CII 2019 has presented that opportunity framing is one of the key phases for maximizing the modularization, for implementing the standardization, for achieving the higher level of standardization. And the key tasks and opportunity framing includes market analysis, business drivers validation, development plans, get management commitment. These things are all related to the decisions of standardization. Similarly, the top two ranked critical factors for implementing standardizations includes alignment and approval of standardization decisions, as well as standardization early identification. And these all activities should be done as early as possible to gain the maximum benefits, which highlights that early standardization provides the clarity on the opportunity and risks that the project can have, enabling an informed go-no-go decisions and a deeper understanding of the project scope, which highlights the importance of early decision in standardization also. So we know modularization and standardization bring benefits. We know we have to take early decisions, but even then, the industry has not been able to implement modularization and standardization effectively. And the key reasons are most of the modularization and standardization are information decisions are made without adequate information. They are made at pretty later phase when they are not able to capture the maximum benefits. There is a limited understanding on how to evaluate and then justify both the decisions, and the industry lacks a better understanding to make a definite go-no-go answers regarding modularization and standardization decision, which helps me to sum up that capital projects have limited understanding to analyze and justify early level of modularization and standardization decision. So now let's focus on the existing literature review, and the literature review presents the foundation of this research, presents us with the existing research gap that we need to address and what has been done till now so that we could continue and bring contribute to the industry and the existing body. So the first thing, let's focus on the studies done by CII 396. This is one of the latest contribution in the sector of industrial modularization, and I was also a part of that. The CII 396 has developed a six solution to implement appropriate modularization at the approach for modularization at the appropriate timing period to gain the maximum benefits. The first solution includes standardization definitions that is focused to standardize all the terms and terminologies that are used in modular sector, so that everyone who are using those techniques can have a common understanding, followed by recommended modularization timing, which suggests that the earlier we decide to modularize or the earlier we decide to move towards modularization, the better or the maximum potential benefits we can capture from modularization. The third was the identification of key modularization barriers and barriers breakers. The three tool are business case analysis for opportunity framing that studies the viability of modularizing the project and suggests if we have to go to a deeper detailed analysis or not. So, which is followed by business case analysis tool for assessment and selection that provides a detailed analysis regarding modularizations and respective cost and schedule savings based upon varying percentage of modularization. And the last one was ESC modularization assessment tool that measures and analyzes the ESC criteria or factors that bring both the positive impact and as well as the negative impact to our modular projects. Now, let's focus on the study done by CII RT UMM01. So this is one of the latest study done on industrial standardization. The first one was economics of standardization that highlights the performance level that can be achieved through standardizations. The different metrics that can be achieved was cost, quality, safety. So the first solution highlights how much the standardization can provide on those performance level on those matrices, followed by standardization decision-making tool, standardization business case analysis tool, standardization work processes that needs to be considered, which also highlighted that we need to take early decision regarding standardization, followed by standardization critical success factor and enablers assessment. And the last one was innovative technologies and management approaches that can be used for a better performance and achieving a higher level of standardizing in a project. Beyond the industrial reports, there has been numerous academic reports, studies, research done on the sector of modularization and standardization. If we look at modularization alone, there are numerous research that has focused on use and trends of modularization, advances and key challenges associated, critical success factors, enablers, executive plan differences, and what are the methods for decisions or for cost and schedule success, along with the key decision models at different project phases. And if you look at standardization, then similar to modularization, numerous studies has been done in the areas including use and trend, key benefits and challenges, timings of CSM accomplishment, decision models, and standardization work process. If we look at the initial reports and these academic research and publications, we came to see that there is still a lack of study on decision factors and recipes for standardization and modularization decision at the early project phase, which is also one of the key research gap for my dissertation. Moving forward, currently there are two existing decision models, one each for the modularization and standardization. And the tool for modularization is modularization business case analysis for opportunity framing that was developed by CII in 2023. And the next is facility design standardization decision-making model for industrial facilities and capital projects. Both these tools provide an early high-level analysis regarding modularization and standardization decisions and helps to identify and assess the opportunities related to modularization and standardization. The first tool, that is modularization business case analysis model, has 12 decision factors, and the standardization decision factor has 10 decision factors. If we look at that 12 and 10 decision factors, they are not like independent decision factors. Initially, for modularization, a total of 97 decision factors were analyzed or found through multiple reports, multiple research, industrial models, and tools that has been used. And based upon the subject matter experts and multiple brainstorming sessions and meetings, a final of 12 decision factors has been determined that are the key to the modularization decision. Similarly, for standardizations, from a total of 90 decision factors that has found through multiple literature review, multiple review of decision tools and studies, a total of final 10 decision factors has been kept in the tool. Therefore, which are also considered as a part of my research. Both these tools are for the early project phase, that is for opportunity framing, and the key parties that have to be involved in this phase are upper management, especially program director, program manager, and additional team members that may include procurement and legal team, as well as environmental and other things as required. So basically, these tools has to be used by the key and the top level management for the early decision. Let's now focus on the modularization decision factors. So as I already mentioned, CII 2023 has identified 12 key modularization decision factors. Along with the decision factors, so the first one would be economic productivity factor. So along with the decision factor, the CII 2023 has also defined what does those key decision factors mean and how we can understand and as well as potential inputs that an industry can have, and the key details based upon each of the inputs and the potential output and recommendations that the industry can have. Now, if you look at economic productivity factor has been defined as the ratio of site all-in rate and site productivity to the yard all-in rate with yard productivity factor. And the potential inputs can be two. Either it is one plus or it is between 0 and 1. If it is 1 plus greater than 1, so that means that the module yard cost for labor at the module yard and the labor productivity at the module yard is low compared to the site. And that's therefore the for fabrication yard can be selected for modularization decisions, and modularization is a key option in that case. Similar to economic productivity factor, the other factors that are presented that are included in modularization decision factors includes schedule constants, extreme weather, site data area ratio, site labor availability, HS health safety challenges, quality performance and quality risks, whether it is a brownfield or a greenfield, followed by social factors, environmental factors, governance factors, and regulations due to ESG. Similar to modularization decision factors, there are 10 key decision factors for standardizations, and those factors are management commitment to standardization. As I said, like in modularization, here also CI 2019 has provided a detailed description of each of these factors. Like management commitment to standardization is needed because it brings buy-in and champions together. It will help to have a culture which will accept standardizing the process. It will delegate authority and responsibility to all the people who will be involved in standardizations. And there are key factors that needs to be considered, like defined approach, team energy, corporate culture, and defined level of project scope, responsibility. And these all decision factors has been analyzed in a scale of -3 to +3, where -3 means strongly favoring customization, that is opposite to standardization, and +3 means strongly favoring standardization. So similar to standardization decision factors, management commitment, the other decision factors included are development plan, standardizing work processes, project execution plan, market analysis, and its number of standardized project units, technological maturity, as well as economic evaluation. Moving forward, now based upon our background of the study and based upon the existing literature review, now let's see what are the key needs and hypotheses that I'm going to cover through my dissertation. So as we know from the literature review, that the key problem of the industry is that capital projects lack an adequate understanding of the decision factors as well as modularization decision factors at early project phase, as well as their collective and combinational effects on modularization and standardization decision. Based upon that, the research need that we are going to address are: there is a lack of study on decision factors and recipe for modularization decision. There is a lack of standardization decision factors and recipe for standardization decisions, and there is a limited understanding of decision factors and decision between modularization and standardization strategy. Right now, we are talking about different strategies, but what are the commons and differences between those two strategies? Can we relate them together, or can we do it together? And when you will see, we'll compare those two strategies, and we'll try to see what the industry can do to bring them together or can learn from each strategies. So based upon the research need, the key research objectives that I'm gonna do for the dissertation are: 1, investigate the modularization decision factors and study the combination and collaborative effects of these decision factors on modularization decision. The second objective is investigate the standardization decision factors and study their collaborative and interactive effects on standardization decision, followed by the comparing the modularization and standardization decision factors and decisions through descriptive and QC analysis. So the research questions that will direct me for the analysis and to address the research objectives are: how are modularization decision factors related to the modularization decision, and if there are any combination and combinatorial effects of these decision factors on modularization decision? Similarly to modularization, the second question is: how are standardization decision factors related to standardization decision, and if there is any combinational effects of those decision factors on standardization decision? And third is: is there any similarity or differences between the analysis obtained from descriptive analysis and the findings from 1 and 2, along with the comparison of this modular and standardization decision that we do it in objective 1 and objective 2. So the key research hypothesis is for the null hypothesis for modularization decision is that there is no combination or collective effects of modularization decision factors on modularization decision. And for standardization decision also, the null hypothesis is there is no collective and combinational effects of standardization decision factors on standardization decision. So let's see what research scope I'm going to cover. So my research is basically is limited to the capital projects, and it is focused on the early project phase, that is opportunity framing. The timings of data collection for modularization was between the period of 2022 and 2023, whereas the data for standardization was collected in the period of 2019 and 2020. And the data from actual projects that has implemented these strategies that has is only considered, and the sources of the data were from the CII member companies. So CII represents a world-renowned owners, contractors, and clients who are basically involved into capital projects, and they are implementing modularization and standardization as one of the key strategies in their projects. Moving forward, let's discuss the method that I have used to answer my research questions and to achieve the research objectives. The first step was to identify the research problem and research need through extensive literature review and determine the research questions as well as research objectives, followed by the data collection part. So as I already mentioned, for modularization decision factors, I have collected the data using modularization business case analysis tool for opportunity framing developed by CII 2023. And the members who participated for data collection are the research team or the subject matter experts from CII Article 96, and a total of 16 actual projects that has implemented those projects has been collected. Similarly, for standardization decision factors, standardization decision tool developed by CII 2019 has been used, and the members from CII RTUM01 participated for the data collection, and a total of 8 actual project data has been collected. For objective 3, we are going to conduct the descriptive analysis and compare the QC analysis that we will do for objectives 1 and 2 to further simplify our research. Here, we have collected the actual data instead of random sampling, because as we know, the actual projects that has implemented these strategies and in capital projects are very really limited, and the projects that we have collected are all across the world, including US, UK, Saudi, and India, and there are other parts where we have collected, so they are very rare. And second, since we know these are very large scale projects up to from 500 million to 5 billion, so there is a company willingness, they don't want to share any of the data for any research purpose, because it is very competitive and very so they don't want to share. And the third is there is the very limited numbers of subject matter experts who really know about modularization and standardization at that upper level, so which makes us limited to, and we haven't collected the data from random sampling method. Now, based upon the data collected and to cover the research objectives, the following comprehensive analysis and techniques methods have been used. So for objective 1 and objective 2, QC analysis has been used to compare the test the hypothesis and consolidate the findings. And for objective 3, descriptive analysis that is being conducted to compare the descriptive findings with the analysis of QC findings, as well as comparing the decision for modularization and standardization decision, followed by the key conclusions and recommendations to the industry based upon our research. As I already mentioned, a total of 16 projects has been collected for modularization decision factors analysis, and a total of 8 projects covering 4 standardization and 4 pro-customization has been collected for standardization decision factors. As we know, for objective 1 and objective 2, we have used QC analysis. So what is QC? QC stands for qualitative comparative analysis, and it is a research approach as well as data analysis technique. If we look at QC as a research approach, then it is case oriented. That means it collects the actual case and to collect the in-depth data from those cases, and then it compares those cases or the collected data to have a general some level of generalization among those factors, and then it establishes a set theoretic relationship where it establishes, when based upon analysis, it establishes the superset and subset analysis that is basically called necessary and sufficient conditions from the QCA analysis. QCA provides a balance between small n and large n, and if you look at the literature review, and there are a few applications that have used very small up to limited up to 4, 6 cases and 7 cases, and this has been a benchmark for the future research. Initially, when QCA was designed, QCA was basically used for political science and social science, where the decision has to be made based upon the context, and there were not enough data that can be used for statistical analysis. However, if you look at the last decades, then a lot of sectors from construction and civil engineering has been successfully using QCA approaches for different research analysis. Some of them include capital projects, use of BIM, project management, decision making, and safety. Regarding others that has used the QCA successfully and that has been able to produce some valuable results to the industry. Moving forward, so there is a separate methodology for the QCA approach, which we are going to use for our objective 1 and 2, because we need to understand the comprehensive analysis of the combination of decision factors for the modularization and standardization decision. So first step in the QCA is based upon the data collected, we need to determine what QCA variant are we going to use. There are 3 types of QCA variant: CSQCA, FSQCA, and MBQCA. And for my research, I have used CSQCA. Actually, CSQCA is one of the most simplest and popular method, but it is not the reason I have selected here. So CSQCA allows data to divide into 2 distinct groups, whether they want to go for modularization, whether they don't want to go for modularization. So clearly 2 distinctions can be achieved, and QCA allowed it for that victimization. There was no loss of information and data richness, and it fulfilled all the selection criteria that includes there was a balanced positive and negative case, there was no counterintuitive configurations, and there was the presence of adequate variation for each conditions along with presence of cross-section diversity. So the next step for QCA analysis is to determine the causal conditions as well as causal outcomes. So for modularization decision, the causal condition was whether that decision factor is a distinguishing factor or not. If that factor is a distinguishing factor and that factor is driving for modularization, then it is given as a full member, and the value of full member will be 1 based upon the Boolean algebra that the CSQC uses. And if that factor is not driving, or if that factor is not a distinguishing factor, then it is given non-full member, and the value of the non-full member will be 0 based upon CSQC binary configuration. Similarly, for causal outcomes, if the project has decided to go for modularization decision, then the project is given full membership and with a value of 1. And if that project has been designed and developed based upon stake build approach or stake build decision, then that is given non-full member with a value of 0. Similarly, to modularization, if you remember back, the standardization decision factors has been evaluated on a scale of -3 to 1,3. So it was not clear, like modularization, on how to classify those factors. Now, before we classify, we need to understand that QCA provides a strength to define the causal conditions based upon the theoretical basis and theoretical knowledge. So, as we know, customization is way popular and widely accepted if you look at today's scenario than standardization. But this focus today is focused on standardization. So we are focusing on something that is less popular compared to customization that we have to keep in mind. Similarly, for this analysis, I have provided the value of -3 to +3 as a full member. Why? Because it has a strong supporter of standardization, that is from 1 to 3, and the neutral and mildly opposing decision factors has also been considered as a full member because that may still adopt standardization. And one of the key bases for selection of -1 in this analysis is that the study done by Choi et al. In 2020 has suggested that the average value of pro-customization project is 1.42, or that is greater than 1. And so -2 and -3, that clearly reflect, or that clearly opposes the standards are only considered as a non-full member, and the other factors are considered as a full member based upon for the QC analysis. Now, for the causal outcomes, if the project has been designed and developed for the standardization decision, then it is given as a full member. And if the project has used the customization decision or the customization decision, then it is given as a non-full member with a value of 1 and 0, as we already discussed in CSQCA. After defining the causal condition and outcomes, we need to further analyze whether all those the decision factors or that we selected are sufficient or good enough for the analysis or not. And in QCA, it is done through a comprehensive approach. Here, once we define the causal outcomes and conditions, we check whether if any decision factor is accomplished by all the factors or all the projects, then it is definitely important, right? We don't have to do further study to determine whether it is important or not. So such factors can be removed. However, for our analysis, there was no such removal because there was no such conditions that has been achieved in all the projects for both standardization and decision and modularization. Similarly, we need to check if there is some missing value that will prevent us from the QC analysis, and we need to interpret those values separately through the theoretical basis or through the actual projects. For modularization, there was no such removal, but for standardization, we have removed 2 decision factors out of 10, that is market analysis and technological maturity, which I'm going to further show in our analysis. And the third was, if there are any decision factors that do not actually support modularization and standardization, then they can also be removed. But as we know, these decision factors has been are very important decision factors, and none of those decision factors were there that do not support the modularization and standardization decision. So there was no such removal regarding the pertinence that do not display the decision. So as I already said, all the decision factors in modularization has been considered. For standardization, market analysis and technological maturity has not been considered for the further analysis. They do not qualify for the QC analysis. Now, moving forward, the next step we need to understand in QC analysis is the necessary condition and sufficient condition. So what is necessary condition? So necessary condition has been defined as a condition that must be present when there is an outcome has to occur. When there is an outcome, then that factor is always present. And for sufficient condition, it means the presence of that factor guarantees the occurrence of the outcome. To simplify this, let's understand, if we need a coffee, then what is the necessary condition? The coffee powder has to be there, right? Whenever there is a coffee, there has to be a coffee powder that is used to make that coffee. So coffee powder is the necessary condition, whereas coffee powder alone is not sufficient. So a coffee powder plus cup can be sufficient condition for a coffee, or a coffee powder plus sugar can be sufficient condition of coffee, whereas a sugar plus water is not a sufficient condition for a coffee. So we need to understand what combinations are sufficient and what combinations are necessary to understand the necessary and sufficient conditions for QC analysis. Now, the sufficient condition has been again divided into 3 solutions. The first is complex solution, parsimonious solution, and intermediate solution. So, what is complex solution? The pro of complex solution is that it only makes assumption based upon what has been observed. It doesn't make any reduction based upon any unobserved cases. It only focuses on what is there and what has been collected and what is the real combination right now. So it can yield complex results that are very difficult to interpret because there is no any further reduction done. Whereas for the parsimonious solution, it yields the simplest of the simplest result, and it uses the unobserved cases also to make the solution simplest format. However, the con of the parsimonious solution is that it does no evaluation or understanding whether the unobserved configuration that has been used in analysis actually has a real makes a sense or real if there is a real project that has been using those combinations. And the intermediate solution solves the con of both the both the complex and parsimonious solutions. And in the theory or in practice, a lot of the research has been focused on intermediate solution and parsimonious solution to understand what solutions are the best, not complex, but the best as well as most the simplest form that can be used for decision making. And in our case, that is modularization and standardization decision. Moving forward, so I have conducted the FSQCA analysis using FSQCA 4.1 software. There has been different softwares like R programming, Tacoma, and a few others things that has been using that we can use for our analysis. But if you look at FSQCA, then if FSQC has a lot of strengths regarding analysis for data interpretation and how we classify all those data. So based upon the strengths of FSQCA, I have used FSQCA's 4.1 software. It is based upon Quinn-McKelvey algorithm and helps us to determine the necessary condition and subset condition, and then further reduce the subset condition into complex parsimonious and intermediate solutions. Moving forward, so we knew what was the problem, we knew what we were going to achieve, we know what methods have been done, and now let's see what has been done or what the analysis of those actual process has been solved. So we'll go here objective by objective. We will focus on each objectives and try to see the results based upon each objective. So for objective 1, so this was the raw data collected. As I already said, there are factors that is a distinguishing factor in a project, and some of the distinct factors may not be distinguishing factor in a project. So if each row represents a project and each tick represents whether that factor was used or is a distinguishing factor for that project or not. So a total of 16 projects has been considered, and since there is no loss of information or there was no value missing, so all those distinct factors have been considered. And now, if you remember, I have defined that if the factor is using is a distinguishing factor, then that is given 1, and if that factor is not a distinguishing factor, then it is given binary number 0 for the CSQC analysis. So based upon the causal outcomes and condition definitions, the raw data has been converted to now the truth table. So each row represents a new configuration that can lead to modularization and more like that can help us to decide modularization and standardization decision. The outcome, if the project has decided for modularization decision, then the outcome is 1, and if that project is gone for the stick build decision, then the project is gone for outcome is 0. So each represents the different configurations that we have seen, and we are going to further reduce it into necessary conditions and subset conditions for our analysis. So the first step was to find the necessary condition of the QCA. So based upon our analysis, we see that the minimum threshold for the necessary condition was 0.9 based upon the literature, but none of the 12 decision factors have that consistency or anything greater than or equal to 0.9, suggesting that none of the 12 decision factors that we consider are sufficient, like are necessary alone for choosing modularizations. And at this point, we can understand that maybe modularization was not because of a single factor, but rather it was a result of a combination of decision factors that lead to the modularization decision. And further analysis is done to find the sufficient conditions. So the next focus was on intermediate solutions. So a total of 6 configurations has been identified, where P means the present of that factor in that each configuration, and A means the absent of that configuration in the configuration. The necessary threshold was the consistency threshold was 0.8, and we see that all the 6 configurations has a solution consistency and a coverage of 1 that helps us to that suggests that these configurations identified with the intermediate solutions are sufficient to define the modularized conditions. We are going to further discuss what are those configurations. So the first configuration was MD3, MD4 in the absence of MD7. That means when we have an extreme weather condition in our project with there is enough site laydown area ratio, then even in the absence of quality performance and quality risks, modularization decision can be taken, and the project can opt for that path and have a modularization decision. And similarly to that, if you look at 6th configuration, then it says the modularization can be the result of a combination of schedule constants, extreme weather, site laydown area ratio, site labor availability, environmental considerations, social factors, and governance factors and regulations. So we see intermediate solutions provides multiple configurations. Some are simple, like the first and second one, whereas some are complex and includes more factors, like the one in the 5th and 6th, which includes multiple factors. And if you look at all 6 configurations, then we see that almost all 12 of the decision factors are present there in some combinations, and each combinations can independently lead to the modularization decision in the project. The next step was to determine the parsimony solutions. So the intermediate solutions that we obtained were further simplified to understand, to make it easier and simpler. And where we see the 4 configuration, and each configuration and the overall solution has a consistency and coverage greater than 1, suggesting that they are able to justify or define modularization decision. So if you look at 4 decision factors, the first one was, even in the absence of extreme weather, the quality performance is sufficient enough for modularization decision. And similarly, economic productivity factor and site labor availability are sufficient for modularization decision. The third was site labor availability and environmental consideration are sufficient. And the fourth one is extreme weather and site around area ratio are sufficient for modularization decision, even in the absence of quality performance and risks. If we look at configuration 1 and configuration 3, what we saw is that extreme weather, that is MD3, and quality performance MD7 are compensating each other. Like the presence of one doesn't require the presence of other, and they are compensating each other. Also, out of 12 decision factors that we initially considered for modularization decisions, only 6 are needed for parsimony solution all those equations. That means the other factors, other 6 factors that are not present in the parsimony solutions, they can be compensated with the presence of these factors. That means a project doesn't need all those factors. They can go for a configuration. Some of these factors may not be needed, and they can be compensated with the presence of other factors, and then even then it can lead to the modularization decision. Moving forward, let's see what were the key highlights. So we saw there was no necessary conditions. None of the 12 decision factors is sufficient alone or is always necessary to be in the necessary whenever there is modularization decision. The recipe or the way for modularization decision is through the combination of decision factors, and we don't need the combination of all those 12 factors. There are 6 configuration in intermediate ways and 4 in parsimony solutions, which can lead to modularization decisions. And the 6 decision factors identified in the parsimony solutions are sufficient enough for modularization decision, while the remaining 6, we don't want to mean that these decision factors are not important for our project. We just at this point we want to say or conclude that these decision factors can be compensated through the other decision factors that are present in that project. And intermediate and parsimony solutions validate that there is a collective and interactive effects of decision factors for modularization decision. Now let's look for the standardization decision factors. As already said, first we collected the data. Here the data was obtained in a scale of -3 to +3, if you remember from the tool. And from -1 to 3, we did it as a full membership and provided with a value of 1. And for the other value, -2 and -3, we provided the value of non-member with a value of 0. Now, if we look in project 6, there is no SD4, that is market analysis. And in project 2 and project 5, there is no technological maturity. We understand that in the early decision factors, all of the 12 decision factors may not have been analyzed or identified in a project. So the chances that they are not considered or not evaluated in the early project phase can be high. And now we need to protect the data richness as well as valuable information that those data has provided. So I did multiple iterations as suggested in QC analysis, and the best solution was to remove SD4 and SD9 for the QC analysis and proceed with the remaining data. So based upon that, the data is converted into truth table as we did it for the modularization, where the full member is provided with 1 and non-full member is provided with 0. Outcome that goes for the standardization decision has a value of 1, and that goes for the customization decision has a value of 0. Now, in modularization, there was no single decision factor that had a threshold of 0.9 or greater than 0.9, whereas for the standardization decision, all the factors that were identified has a consistency greater than 0.9. That means all these factors are required for standardization decision. That is the result of necessary conditions. Moving forward, when we did the sufficient conditions, now from the necessary conditions, we knew all those factors are needed. So as expected, the intermediate solutions gave only one single configuration, and that said all these decision factors are needed for the more standardization decision. And since the coverage and consistency is greater than 1, the single configuration consisting of all the 8 decision factors considered are sufficient for the QC analysis. So even then, we know parsimony solution further reduces the solution to the simplest form so that it is easy to interpret and analyze. So the parsimony solution from QC analysis suggested that only ST1 and ST6, that is management commitment to standardization and economic evaluation, was sufficient enough for the standardization decision. So if we go ahead. So if we have a management commitment, and as well as if we know what value we can present to the economic evaluation, then definitely we can have a standardization decision in the project based on the parsimony solution. Moving forward, so the key highlights were all 8 out of 10 decision factors that has been considered for standardization decisions are necessary conditions, and the standardization decision is more conservative compared to the modularization decision, because here they require all those factors to come and align together. And while the remaining 2 decision factors, market analysis and technological maturity, has not been considered due to insufficient data in for the QCA, those also have to be analyzed in the actual projects to identify if there is any underlying opportunities that can come along with those factors. And as in modularization, the intermediate and parsimony solutions have validated the collective and interactive effects of standardization decision. Moving forward, now the third step was to compare and see how the actual projects are coming, what's the differences, or how the QC analysis gave the result, and to compare the modularization and standardization decision. So if we look at the modularization decision factors in pro-modular projects that operate for modularization decision, the number of decision factors in a single project ranged from 3 to 10. Some projects had only 3 decision factors that was sufficient enough for modularization, and some projects depended upon up to 10 decision factors out of 12 for modularization decision. Whereas for stick build projects, the factors there were like from 2 to 6. One of the interesting things that we have to focus here is that even the stick build projects, there is some modularization, pro-modular drive decision factors that are coming in the project. What does that highlights? That highlights that if the projects decided to go for a stick build method, even when there are some decision factors that can drive the decision, that can lead to the modularization decision. So each project needs to be analyzed for any of the underlying modularizing benefits at early project phase, so that no opportunity from modularization is missed in the later project phase. So similarly, the next step was to find what decision factors out of 12 were the key, are the most prevalent or most common, and which one is coming among the modular and stick build approach. So what we saw is that in pro-modular projects, the top factors that was driving the modularization decision was site labor availability, followed by schedule constraints, extreme weather, and site labor area ratio, all coming across in more than 50% of the projects. Similarly, even in stick build approach, in stick build projects, there are 2 decision factors that are above 50%, and they are site labor availability and schedule constraints. If we look at both these projects, modular as well as stick build, what we found is that site labor availability and schedule constraints are the key decision factors in both the projects. Why? Because we need to understand that most of the capital projects, as I already said, are in very difficult terrain or in difficult topographic region, where the availability of skilled labor force is very difficult. They can be there, but it can be very difficult to keep all those skilled force over there. There is a very limited skill availability, and the projects are have a very tight schedule, and that is always in pressure. And if we consider modularization in those projects, then as we know, in modular projects, a lot of on-site work is taken out the off-site location where the labor availability can be cheap, where the labor availability is easier, and the schedule constraints can also be met through a parallel alignment process. Like if the work of related to foundation is going on in the site, then we can also build a superstructure in the factory on the fabrication yard and then bring it together so that we can match the schedule constants. So these things we need to consider. Similarly, the next step was to conduct the descriptive analysis of standardized decision factors. And when we conducted the analysis from the actual process, we found that the management commitment to standardization and standardization work process are the key factors that is impacting the standardization decision. Similarly, for customized projects, marketing and market analysis are the key decision factors that are driving. So, and if we compare the standardized and customized projects, we see two of the factors that are in the top rank in standardized projects, where in the low are in customized projects, and that are specific to standardization process are standardization process and work process and technological maturity, which from the actual projects is suggested that if we focus, these two are, most of the factors have a similar range, but the factors that is differentiating from standardization with the customizations are standardization process and work process and technological maturity. Moving forward, if imagine we are in a room of decision makers and we want to decide to go for standardization or not, we want to decide whether we want to go for standardization or not. So there are a few factors that are the top influencing factors, right? That can derive, okay, because of this, let's go for the standardization, or because of this, we can move for the customization. So we need to understand, if we want for standardization, effectively implement standardization, we need to understand what are those top influencing factors that are driving the decisions. And based on the analysis, it was found that management commitment to standardization and marketing are the top factors that are influencing the decisions. That means if the management is preoccupied with that, no, I'm going for the customization, then it can be very hard for convincing, for driving the decisions for the standardization. Thus, we need to have a early management commitment where the authority has been designated. There are buy-in and champions that focus on standardizations, and the whole management is aligning for standardization, then that can lead to standardizing. Similarly, next thing is marketing. If the decision makers, they don't understand, they are reluctant to standardization, then if they are not receptive to those new strategy, then it can be also be very hard. So all those factors, the marketing, that means the owners, the stakeholders, they should be receptive to standardization. They should be receptive for those the value and the benefits that standardization can bring. Then they can also move towards the standardization decision. So these are the key decision factors. Moving forward, the third objective was to compare the actual descriptive analysis with the QC of modularized decision. If we look at the QC analysis in modularization, there was no single condition, or if not in a single project, there was only one factor that was driving the decision, which was similar with the descriptive analysis, because we saw that projects ranges from 3 to 10, and there is a combination of different decision factors that is leading the decision. Also, the next step was to compare the parsimonious solutions. So we know parsimonious solutions give 6 decision factors for modularization decisions. If we look at all those 6, they quite have a high prevalence or high repetitive percentage in the actual projects. Whereas schedule constants, though it is one of the top factors in actual projects, it was not available in the QC in parsimonious solution, which means the schedule constants, though it is considered very important and one of the key factors for modularization decisions, the parsimonious solution suggests that, okay, the schedule constants, though it is important, it can be compensated with the presence of other factors, like if we are able to manage extreme weather and site level availability, maybe we can solve, we don't need schedule constants, or the combination of other factors or any of those configurations that we identified are sufficient enough to compensate for schedule constants. Similarly, in intermediate solutions, we saw that all those decision factors are present, which is similar to the actual process through the descriptive analysis. Moving forward, in a standardization decision, all factors are necessary conditions, and which is similar to the QCA. And in the parsimonious solutions, if you come back, you will see that management commitment and economic evaluation are sufficient for the standardization decisions. But if you look at the standardization project, then the economic evaluation was valued as the last factor that is used, that has the impact on standardization decisions. That means currently the industry practices, they are not evaluating economic, they are not prioritizing the economic evaluation of the project. However, we know once we have a management commitment along with the economic evaluation, if we know the actual value that a standardization can bring, then definitely it will be a help to convince them better. Once we know the value, once we know the benefits that it can bring, thus the combinations is important, and we need to have that economic evaluation as early as possible, associated by the QC analysis. Similarly, we also found the top decision factors that are quite similar, because in intermediate solutions, there's all these factors has played a role, or all the combinations was there in the intermediate solutions, whereas actual process has also ranked similarly in the similar pattern for the decision factors. Now, let's compare the decisions between modularization and standardization. We know what are the factors needed for what are the configurations needed for modularization decision. We know what are the combinations needed for standardization decision. We know what's the differences between actual projects and the QCA findings. We knew what factors are not considered or what factors has to be considered. We knew. Now let's compare between those two strategies. In modularization, there was not even a single factor that is needed for the necessary conditions, whereas for standardization, there was all those factors was needed. All those factors has to come aligned for the standardization decision. There are 6 different configurations leading to modularization decision, whereas there is only a single configuration for standardization decision. Similarly, if you compare the parsimony solutions, there are 4 simplest solutions that can lead to modularization, and there is only one configuration that has all those decision factors for a standardization decision. So what does this mean? How do we interpret those decisions? We see in recent years, in last few decades, in last decade, modularization has been widely used, and it is becoming increasingly common in capital process compared to standardization. As a result, there has been multiple pathways has been identified in the QC analysis that can lead a project for the standardization decision. Whereas since standardization is a relatively new strategy compared to the modularizations, and practices currently are adopting very conservative approach. They want all those alignment. They don't want to have a failure of the project, and they want all those factors to align. Or that means they are not confident, and they want all those factors to align for the standardization decisions. And comparing those modularization and standardization, what we can say that if the standardization gains a broader acceptance and gets matured with time, then definitely the decision making and the decision process in standardization will also be is expected to be less conservative, and then multiple success pathways are likely to emerge that can lead to standardization decision. So let's see what are the key highlights from the objective 3. We saw that even stable projects have certain benefits that needs to be captured. So all projects has to evaluate for any modularization benefits that we can capture as early as possible, and the decision to. And if you look at between standardization and customization, for standardization decision, the key factors were standardization work process and technological maturity that needs to be focused, that needs to become aligned for a project for standardization decision. The key factor that we need to think that can influence the decision from the decision makers regarding standardization and customizations are management commitment and marketing. So those factors has to be addressed. And yeah, the schedule constants was not identified in the parsimony solutions. However, in the real projects, we saw that schedule constant is one of the common factor. That means the QCA solution is suggesting that other factors can compensate those factors. So we need to be project specific. We shouldn't find on hey, there was no schedule constants, so we are not going for the schedule. It's not like that. We need to see what factors or what combinations as identified in our result are sufficient for the standard modularization decisions. Then we can go for the standardization decision in a more informed or being more confident on that. And despite economic evaluation is not currently considered as the top factor, but QCA suggested that economic evaluation along with the management commitment can play a key role can lead to the standardization decision. Thus, both these factors should be analyzed, and that can help to that can lead to standardization decision. So based upon the research analysis that we did, now let's conclude what are the key findings and what are the recommendations that the industry has to focus from our research. So first, let's look back what we did. So our first objective was to investigate the modularization decision factors and their combination and collaborative effects. And here we found that there was no single necessary conditions, whereas there are 6 intermediate solutions and 4 parsimonious solutions that can lead to modularization decision. Similarly, for standardization decision and decision factors, all factors are necessary conditions based upon our research, and there is only one single solution which aligns all those 8 factors identified as to in both the intermediate and parsimonious solutions. And when we compare between the modularization and standardization decision factors and decisions, we saw that both all the projects can have some modularization benefits that has to be achieved. The schedule that needs to be evaluated, and standardization decision process and technological maturity has to be aligned for standardization decision, and the decision to standardize is a bit more conservative compared to the modularization decision based upon our research. Looking forward, we saw that there is a growing trend on adopting the modularization and standardization from based upon the experiences from learning from the shipbuilding and other manufacturing industries. The construction sector has been also receptive of these methods. The combination, when we combine modularization and standardization together, they can yield additional benefits. And the decision to modularization and standardization is through the combination of different decision factors. If we have to think about this modularization decision only, then we need to explore early modularization potential for all those projects so that no any opportunity is mixed. And we have to see that we need to know that multiple configurations or combinations of decision factors can lead to for modularization decisions. So we don't have to stick to a specific decision factor. We can test different combinations as identified, and that can lead. Similarly, missing decision factors can be compensated by the presence of other decision factors, and modularization decision is it's a bit flexible compared to standardization. Similarly, for standardization, it still remains a conservative approach, and the results suggested that we need to align all those factors, and leadership, support, management commitment, and economic evaluation can play a key role for standardization, can lead to standardization decisions. So we need to be careful on that. And with broader acceptance in the future, decision making in standardization is expected to be less conservative, and then multiple successful pathways can emerge, and that will lead to standardization decision. So the key recommendations for regarding modularization decisions are: consider all decision factor combinations, use identified configurations based upon the project, focus on 6 key decision factors as identified in parsimony solutions, but that doesn't mean all other factors are not important, but focus on 6 and evaluate every project for potential. Similarly, standardization decision is right now, based on the result, it says consider all those factors, but we need to prioritize early management commitment and economic evaluation, and establish a standardization work process and technological maturity. That means with the development of maturity, technology things, standardization decision can improve, and avoid overly conservative approaches, because we know from modularization that there can be flexible way for standardization. So we need to be less conservative and start adopting modularization standardization decision and see what standardization opportunities can we gain. The contribution to the existing body of knowledge was we had a better understanding now of regarding the decision factors and the combination of those decision factors. The research also identified the most prevalent and important decision factors. The study identified the key and influential decision factors, as well as had now the research provided a comprehensive understanding regarding modularization and standardized decision and decision making. And similarly to the industry is that we offer different configurations right now, configurations from the dissertations that can lead to for modularization and standardization decision, and provide a deeper insights on those decision factors. And now we offer a comprehensive understanding on modularization and standardization decision, and contributed to more informed decision making in the future projects. Now, the industry can have a better see what factors are coming in play, and now they can more confidently play and adopt and select the modularization strategy for their projects and standardization strategy for their projects. So the limitations, as we know, this project was focused only on the capital projects, and The project data at the current existing scenario is very limited. So we had to do as much projects that we collected. It was the input of all the subject experts that we can get through the team, and we try to collect projects all over the world. And actually, the project data is almost the sample size in the whole population is almost same, because there are very limited projects data, and the results are based upon the current practice industry trends. And it will definitely, once we have a better informed decision, now the industry is going to be more flexible and go towards decision, and the result will evolve with the time, and we need to be careful on that. And the future research are, we need to expand the research source for capital projects, so we can expand it for building and commercial sectors. We can also evaluate the decision factors at the later project phase, so that even if in the early project phase, if we do not see or any modularization or standardization potential, we can analyze the decision factors at the later project phase, like in the assessment and design phase, and see if there are some modularization benefits or standardization benefits that we can capture. So we need to focus on that. And we need, so like I initially told, in 2013, only limited survey participants responded that we need to consider the business case in the early project phase. Whereas after 10 years in 2023, a lot of the participants believe that no, we need to consider have early decision making. So if like that, we need to conduct the similar research in the future, so that we can refine those findings and see if there are other multiple configurations. Like in standardization, maybe after 5 or 6 years, once they start adopting new technology is coming, and once they try to have a management commitment, and then a better or new configuration can emerge. So we need to be focused on that. And there are different strategies that can link or that can improve the modularization and standardization implementations, like contractor strategy and scheduling strategy and logistic plannings. And right now, what we are seeing is that use of AI and other technologies that can immensely improve for the implementation, for the design of modularization and standardization projects. So we need to focus on that thing, and to understand how we can make a better and adopt the standards and implement both the strategies. So we need to focus on that. So these are the future research areas. I would like to thank CII, because they gave me, I was a part of CII 396, and currently I'm working with CII 4021 on the research, and it was a great opportunity. Similarly, I would like to thank University College of Engineering and UNLV for providing me the opportunity to complete my, to do my